Hi everyone, welcome back to Art of the Part. In this video, we're going to take a look at programming first operation for the bracket exercise P1 in MasterCam. So in SOLIDWORKS, we looked at this model and we went through a series of revisions from P1 to P2 to P3, and we found out using FEA studies that P1 and P2 would actually fail with the applied load rating, and we ended up with a final model for P3 that did pass. However, I want to still program P1, P2, and P3 inside of MasterCam because I want to show you what revision management looks like in this software. So I currently have the bracket exercise P1 from SOLIDWORKS opened up here in MasterCam. And before we get started, I just want to make sure that you are working inside of the correct units of measurement. So if the bottom right hand corner, you want to make sure that you are seeing inches. If you do not see inches, we're actually just going to go up here to the top left hand corner to File. We're going to click on File. From this drop down menu, we're going to look for Configuration. So click on the Configuration tab. And inside of Configuration, you just want to make sure that your current config file is set to inches, as well as the units for analyzed measurement is set to inches as well. So if you see metric in either one of these selections, just hit the drop down menu and change this to inches, and then you should be able to hit the green check mark. So now that you're in the correct units of measurement, we can go ahead and get started with the programming process here. And we currently have this file brought in from SOLIDWORKS. So bringing a SOLIDWORKS file into MasterCam, you are going to have some mismatched views. So if you right click here in the viewport from this drop down menu, if you click on top and we look at the top view, we're actually looking at the front view of the model. So we want to rotate this around so that we are looking at the top view of the part so that we can use that G17 command so that the tools are perpendicular to the surfaces that they're cutting. So in the bottom left hand corner, we are currently in the Toolpaths tab. You should see Toolpaths, Solids, Planes, Levels, Recent Functions, so on and so forth. We're going to go inside of the Planes tab. So click on Planes, and just like what we've done before, we're going to create a new plane so that we can rotate this model around so that we're looking at the top surface of this part. So in the top left hand corner here inside the Planes tab, we're going to go and find this green plus button. Click on the green plus button, and from the drop-down menu, we're going to go and select the dynamic selection. So we're going to click on dynamic. And then when you move your mouse out here into the viewport, you're going to see a gnomon attached to your mouse. And I'm just going to rotate my model around and zoom out a little bit, but we can currently see that the Z-axis is still facing towards us. We're probably going to want to rotate this around here in just a second, but I want to place this gnomon first and then we can rotate it around later. So I want to attach this here to the top surface of this diameter or the circle here. So either one of these top surfaces or these top edges for this cylindrical surface, we're going to click on that and we're going to relink that gnomon to that top edge. So like I was saying before, the Z-axis is still facing towards us, so we're going to have to rotate this around so that Z is facing up. So if you're using the three-finger rule, we currently have X, Y, and Z, and we want to rotate this around the X-axis so that Z is facing upwards. So we're going to actually click on any one of these red segments. This is going to allow us to rotate around the X-axis. So we'll click on this red segment right here. And just as an important reminder, we want to make sure that we are currently rotating inside of the compass. This is going to allow us to do 5-degree increments. If you're outside of the compass, you're just going to get wherever your mouse is going to click, and that's where you're going to drop it. So this is 50.78. That's going to be 63.31. However, if you're inside here, I'm seeing -75 to -80, -85, and then we're trying to get to -90. So we're going to click on -90 so that Z is facing directly up. And then over here on the left-hand side, we're going to change the name of this plane to First Op Top. And then we'll hit the green check mark. Now, even though that we created this new plane and we're rotating around the X-axis, we haven't relinked the WCS CNT to this new plane, the First Op Top here on the bottom of our list. We are still currently linked to the top plane. We can see WCS CNT there. If you right click out here in the viewport and you select on top, we are still looking at the front view of the piece. So we want to relink this to the First Op Top here. So we'll click on WCS. That's going to be your working coordinate system. C is going to be your construction plane, and T is going to be your tool plane. So once we relink WCS CNT all to the First Op Top, if you come out here into the viewport again and you right click, you click on top, this is going to reorientate us to the top view of the model. So from here, we're going to move over from the Planes tab, We're going to go over here to the Levels tab. So we're going to click on the Levels tab in the bottom left. And we're going to create a new level for the stock model geometry. So we currently have one level active. That's going to be the cut extrude or the bracket exercise P1. And we're just going to go over here to the top left-hand corner inside the Levels tab, and we're going to click on the new level. We're going to click on that green plus button. That's going to add a new level for the stock wireframe geometry that we're about to create. So we're going to rename this level that we just created. So we'll double click on this box right here, and we'll name this wireframe stock, or whatever makes sense to you, whatever you're going to be using for your stock material. We'll hit enter to save that level or save that rename, and we can currently see that we have 0 entities linked to that wireframe stock level that we just created. So we're actually going to have to create a bounding box projection on this wireframe stock level, so just make sure that we have a check mark next to wireframe stock. And then up here in the top ribbon, if you are in the Home tab, you just want to move over here into the Wireframe tab. So inside of Wireframe, we're just going to find this bounding box option. So click on Bounding Box. And before we can make any selections here, we have to actually click on our model first. So we'll click on the model first. And then once it's highlighted in yellow, we'll click on End Selection. And you can see that we are projecting a bounding box around the entire model here. So make sure that you are changing or selecting origin of the center of this model here. If you have it set to any one of these other selections, when you go to apply material or change these dimensions here in X, Y, and Z, you're probably going to go lopsided, or it's not going to go equal in every direction. So we want to make sure that we are selecting here from the center origin, and then our X is currently at 2.5. We're going to change this to 3. We'll hit enter. Y is currently set to 2.625. We're going to change that to 3.75. And then Z is currently set to 0.625. We're going to change this to 1 inch. So we currently have 3 by 3.75 by 1 inch. And again, as long as you have the center origin selected here on the left-hand side, this should extrude or project out equally in every direction. So we'll hit the green check mark to apply that. We can currently see that we have 12 entities linked to that wireframe stock. That's going to be each one of those lines that we just created. So I'm just going to go and right click out here in the viewport. I'll go to the isometric view. And then if we want to link this wireframe to the stock model, which is going to be used for verify, that's that mesh file that we're going to create, we just want to move over here in the bottom left-hand corner from the Levels tab. We're going to go over here to the Toolpaths tab. Inside of Toolpaths, you'll see in the Operations Manager, there is nothing currently activated. We actually have to populate a new machine for us to use before we can actually link this wireframe geometry to the stock model. So up here in this top ribbon here, we're just going to move all the way over here to the right to the Machine tab. So we're going to click on Machine. Inside the Machine tab, we're just going to look for the Mill option here. So we're going to click on Mill. From this drop-down menu, we're going to click on Default. We're just going to create a default 3-axis mill here. So we have a machine group, we have properties, toolpath, blah, blah, blah. So if we go down here to properties, we'll actually click on this plus button to expand this out. We're just going to look for the stock setup option here. So if we click on stock setup, this is going to bring us out into the machine group of this machine here, and it's going to pull us into the stock setup. So very important before we make any changes here, we want to make sure that we are setting ourselves to the correct level or the correct plane that we created. So we have this set to the current top view. That's the old top view. If we hit the drop down menu here, we can relink this to the first op top. So if we click on first op top, this will relink us to that new plane that we just created. And very important as well, we just want to make sure that we have show wireframe entity selected under preview settings. If this is not selected and you go and click on any one of these icons in here, this is actually going to toggle off your wireframe geometry, and you will not be able to select it and link it using the stock setup command. So again, you just want to make sure that you have show wireframe entity selected. And then up here in this top row of icons, we're going to look for a familiar face here, which is going to be add from bounding box. So click on add from bounding box. This is going to pull you into the add from bounding box command. And you could, if you wanted to, relink this to the origin, and you can type in all these values if you wanted. However, if you just click on all shown, it's going to recognize that wireframe geometry that we already created, and it's going to project a new bounding box selection to the extents of the previous wireframe geometry that we just created. So again, you can see over here, X is 3, Y is 3.75, and Z is set to 1. We'll hit the green check mark to apply that stock material there, and then we'll hit the green check mark one last time to save that stock setup. Now, when we created that stock setup, it's actually toggled off. The visibility is off by default. So when you create that new stock setup, it should bring you over here into the Toolpaths tab. So in the top ribbon here, just make sure that you're in the Toolpaths tab. And if you want to see your stock model here, you can actually click on Stock Display, and you can see the red outline of that stock display. If you wanted to see the full shaded view, you can click on Stock Shading. However, I'm not a fan of that. I think it's actually a little bit difficult to select on some of your edges when you have this turned on, so I'm actually going to turn off the stock shading, but I will leave stock display on. Now, we're going to follow the same workflow that we've used before. We're going to do like facing, roughing, finishing, so on and so forth. But previously, I had you look up and populate every single tool that you're going to use. However, in this example for the bracket exercise P1, I want to show you how we can relink a tool library into our model so that we don't have to look for all these tools every single time that we create a new toolpath. So again, you just want to make sure that you're inside the Toolpath tab, inside the ribbon, and we're going to look for this icon called Tool Manager. So it's just going to be a tool sticking out of a collet inside of a spindle, and if you click on that Tool Manager, this is going to open up your Tool Manager window. And there are going to be two different boxes. So on the top box here, this is going to be your magazine or your carousel for the active machine. And this box down here at the bottom, this is going to be your tool library. So you can have any number of tools inside of your tool library, but here inside the magazine, you just want to make sure that you're matching that up to your current machine that you're working in. So if you're here down here in the bottom box, we're just going to copy and paste in a tool library that I've created for you. So if you're in class, you should have access to the Google Drive, and you should be able to download a file folder for tool library. I'm just going to click on this tool library right here. I already downloaded it. And I have an Excel file that if you double click on this is going to open up this Excel file here. This is going to be all the different tools that I populated or I have active inside of our machine, what tool we're using, what holder we're using, the diameter, the radius, the cutting length, exposed tool length, the total length in the holder, as well as recommended speeds and feeds, as well as the recommended depth per pass that we're going to be using as well. So this is all going to be linked inside of this DMU50 IIT tool library folder that I created. And the easiest way to link this into MasterCam, in my opinion, is if you just right click on this file that we downloaded. So this is going to be the tool manager file again, DMU50 IIT, right click on it. From the drop down menu, we're going to select copy. So we're going to copy this to our clipboard. And then if we move back over here into MasterCam, we still have this tool manager window open. We're actually just going to select on this second icon here, which is going to be select a different tool library. So if you click on select a different tool library, this is going to open up the tool library directory. And you can see that this is kind of a pain in the butt to access because we're currently inside the users, public documents, shared MasterCam 2024, mill, tools. I mean, it just goes on and on. So once you are here inside this tools, when you click on that little icon there, it's going to bring you right to this directory. We can actually just right click inside of this directory here, and from this drop down menu, because we've already copied that tool library to our clipboard, if we click paste, this is just going to paste that tool library into this directory here. So we're just going to replace this file destination here, and this is going to be the DMU50 IIT. That's the new tool library. If you click open, because that's what we currently have selected, it should populate the tool library down here with all those tools that I was just talking about here inside of the Excel file. So if we want to copy this tool library into the magazine or the carousel of the machine, all we need to do is select on all this. So I'm just clicking, holding, and dragging, and I'm going to create this bounding box from tool number 21 all the way up here to tool number 1. And then once all of these are highlighted in blue, we can actually just click on this arrow here on the right-hand side of the Tool Manager window, and that's going to copy or project all of those tools into the magazine or the carousel of the machine that we're currently working in. So if you see all 21 tools active inside of the magazine up here, we'll hit the green check mark. And when we go and create new toolpath geometry, we don't have to look for every single tool every single time. We're just going to pull from that library, and we can just pick from the list of 21 tools that we just imported. So let's go ahead and create some toolpath. Like I said, we're going to follow that same workflow of doing facing, roughing, finishing, so on and so forth. So in the top left-hand corner, we're going to be here inside of the Toolpaths tab. We're going to look for the 2D gallery. We'll just select on the face icon here. We're just going to do a simple face mill. Click on face. And this is currently set to wireframe. If it was set to solids, you would only be able to select on the solid model. We want to make sure that we are selecting wireframe, which should be the first option, so that we can get the top edge of the wireframe that we created. So I'll click on one of these top edges, and just make sure that your arrows are going in the correct direction. We want to make sure that the red arrow is going to follow along this top surface here. You can click on the red arrow if you want, or from the wireframe chaining window, you can click on this red fast forward button, click on that 3 times, so 1, 2, 3. That should select the entire top face of that wireframe stock material. We'll hit the green check mark. This is going to pull us into the parameters page, and we're just going to move down here to the tool, and inside the tool tab you can see that we have all 21 tools accessible to us. That's the tool library that we just copied in. No longer do we have to go and select from the tool library and find a tool and populate that here. We're just going to use all these tools that are going to be related or one-to-one to the machine that we're going to be using. So we're going to select on the first tool. This is going to be the 3-inch face mill. You can see that the speeds and feeds have updated. In the comment here, I'm going to title this 3-inch face mill. Okay, then we'll jump down here into the cut parameters. We want to make this a one pass cut, so we're going to change this cutting method here from one way to one pass. This is just going to run the tool, the 3-inch face mill, along the entire face of the width of this stock material that we set up. However, I do want to make mention that when we are setting this up, we want to make sure that the auto angle is turned on. By default, it might be turned off, and I'll show you what happens if it's turned off, because this toolpath wants to run left to right rather than up and down. So we will change the stock to leave on floors to 0, and again, just make sure that you have auto angle turned on. I'm going to leave mine off and show you what happens. Down here in depth cuts, we are going to turn this on because we are going to be removing quite a bit of material here from the top face. And if you look back at the Excel file that you downloaded, we're going to look at the 3-inch face mill, and the recommended depth per pass is going to be 60,000, so 0.0625. So I am going to change this max rough step here to 0.0625, and then as always we want to make sure that we keep the tool down so that the tool isn't going to retract out every time that makes a pass. So make sure that you have keep tool down, and then we'll move down here to linking parameters, and as always you want to make sure that this is set to absolute, 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 and absolute. So on the right hand side here we will change this to absolute, 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 and absolute. Top of stock, if you click on that, we want to link that to one of these top corners of the wireframe material that we just created, so that should read 3/16 or 0.1875. And the depth is already recognizing it at 0, so that's the top face of the new plane that we created. But if we click on depth, we can link this to one of the top edges of this diameter here. And we can see that that is recognizing as 0. So again, I'm showing you a bad example. When I hit the green check mark, this toolpath is not going to generate. That's because I didn't have auto angle turned on. So if I click on the green check mark, again, you should see your toolpath generate. However, I'm getting that this warning that the diameter of the tool is not big enough to make one pass left and right. So I'll hit OK. I am going to keep this operation. I will go back into my parameters page, and I'm going to go up here to cut parameters. And inside of cut parameters, I'm going to turn on that auto angle selection. And then when I hit the green check mark, that will regenerate the toolpath. We will see that toolpath run up and down rather than left and right. So if we just want to see if our toolpath, our stock material, everything is set up correctly, let's just go ahead and select on that basing operation. We'll click on the verify icon. Again, it's that half pipe looking icon in the top row here underneath toolpaths. We'll click on verify. This is going to open up the verify window for you. It's going to take me just 1 second, and then I will expand that out. And then it looks like everything is orientated correctly. The tool is perpendicular to this face here. And then if I hit the play button, we are going to be taking a couple passes there and removing the stock material to the top face of the finished model. So I'm going to back out of verify here. I'll click X. Everything looks like it's set up correctly. I can go ahead and move forward with the rest of my tool paths. So we are going to go into a roughing operation to try to clean up the outside contour of this model. So we just finished up with facing. We're going to go over here to the 2D dynamic mill. If you hit the drop down menu here from the gallery, it's just going to be that third selection, but we're just going to click on 2D dynamic mill. And as we've talked about before, inside the chaining options, we want to make sure that we're satisfying 3 different criteria before we can apply this toolpath. That's going to be your machining region. It's also going to be your machining strategy, and then what avoidance geometry or avoidance region do you want to be considering while we're projecting this toolpath. So we'll start up here with the machining region. We'll click on machining region here. And right now we are currently set to wireframe because we were selecting the top edge for the face mill from before. We're just going to make that exact same selection, so make sure that you are still inside a wireframe. We'll click on one of these top edges here, and just like I showed you before, we can click on the red fast forward button 3 times. So we'll go 1, 2, 3. We're going to select that entire top face there. That's going to be the material that's going to be considered for removal. We'll hit the green check mark. Our machining strategy, do we want to stay inside of that selection or do we want to approach from the outside? For this particular cut, we do want to be cutting from the outside, so we will change this to from outside. I will show you what happens if you leave this as stay inside, but make sure that yours is set to from outside. So I'm going to click on stay inside on mine. And then lastly, we're going to take a look at the avoidance region. So my avoidance region is actually going to be the finished contour of the model because I don't want to cross over and cut through the part. So again, we are currently set to wireframe. I will not be able to select on any of these edges from the 3D solid. So we will change this or toggle this over to solids. So we'll click on solids right here. And then I always just turn off face. I like to work with loops here, and then I'll click on one of the bottom edges here so that I can select on the entire loop of this model, and we'll hit the green check mark. So again, we had 3 criteria to satisfy. We had to make sure that we had a machining region, which is going to be the entire extent of the stock material that we created. The machining region strategy, we want to make sure that this is approaching from the outside because we want to cut through these lines here. However, in mine, I'm going to show you the bad example. We are going to leave mine as stay inside. And then lastly, we want to make sure our avoidance region is going to be the finished contour of the 3D model. So again, we had the 3 criteria set up. We'll hit the green check mark. Move down here into the tool tab. Inside of my tool library, I have 2 different tools that we're going to be using for roughing and finishing outside contours. The second tool here, this is going to be a 5/8 end mill rough. R stands for rough, so this is going to try to remove out as much material as possible. This might not be as sharp as the third tool, which is going to be for finishing operations. That's going to be 5/8 end mill with an F after it. So for this roughing operation, we want to make sure that we are selecting the second tool, which is going to be the first instance of our 5/8 flat end mill. Here inside the comments, we will say 0.625 end mill, and then we'll put rough afterwards. And we'll just jump down here into our cut parameters. Inside of cut parameters, we are going to be doing a roughing operation, so we do want to leave some stock on the walls and the floor. Right now it's set to 50 thousandths. That's just a little bit too much in my opinion. I'm going to go down to 0.005 or 5 thousandths for both of these selections. So 0.005 or 5 thousandths to leave stock on the walls and the floor. Next, we can take a look at our step over percentage. By default, this is currently set to 25%. You can leave that as the default value. However, as you start to increase this value, you might have to start to consider how far you're cutting down with the tool. So inside the distance or the step over here, I will leave this at 25% because I want to take advantage of the full length of my tool so I can take a full length cut. As I start to increase this to 50 or 75%, I will have to actually start to consider depth cuts. However, since this is currently set to 25%, which is a small amount, we don't have to turn on our depth cuts. So we will leave depth cuts off, and then we will move down here to linking parameters. Inside of linking parameters, as always, just make sure that we are registering this as absolute, 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 absolute. So on the right-hand side here, we will change this to absolute, 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 and absolute. For the top of stock, it's still recognizing the top of the material as the top of stock. We do want to update that to the top level that we cut to with the face mill that we just completed. So top of stock should actually register or read as 0. So we're going to change top of stock here to the top edge of one of these diameters here. We'll click on one of those. That should register as 0. And then depth, we are going to project this here to one of these bottom edges of the 3D model. So I'll click on one of these bottom edges. I'm getting a registered depth of negative 0.625 or negative 5/8. And then I just want to go a little bit below that so that we can clean this up for second operation. So we'll go ahead and hit minus 0.0625. So I'm going to add 60 thousandths to this negative value, and we should get a value of negative 0.6875 for the final pass of that depth. And let's go ahead and hit the green check mark. And you can see, again, I showed you a bad example. When I set this up, I had this for stay inside. I will never be able to cross over the extents of the machining region. So I'm only going to be able to cut this much material. However, on yours, if you had it set to from outside, you should see a toolpath generate around the entire model here. So I'm going to go back into parameters, and I'm going to go back up here to toolpath type, and I will change this and toggle it over to from outside, and we'll hit the green check mark. So again, you can see all that toolpath get updated correctly. We are going to be removing quite a bit of material here from the outside to rough out this contour. So let's go to select our toolpath group 1, and we can verify both of these toolpath operations. So we'll click on that half pipe looking icon for verify selected operations. This is going to open up my verify window. We'll hit play, and you can see that we are cutting the face mill as well as the outside contour. I'm going to go ahead and toggle this over to color loop so I can see each one of these toolpaths as different color. So up here in this top ribbon inside of the verify window, we'll go to verify, and we're going to select on color loop, and that's going to activate the color loop for both of those toolpaths. So that looks pretty good to me. However, we still have 5 thousandths on the wall and the floor before we reach the finished edge or the finished contour of the 3D model. So we will have to apply one more toolpath to finish up this contour here. So I'm going to hit X and back out of verify. And then inside of the 2D gallery, we're just going to use a simple contour. If you wanted to, you could probably copy and paste the 2D dynamic mill and then do a stock recognition. However, let's just make our lives easy here. Let's just use the contour toolpath here. So I'm going to click on contour. And again, this is currently set to 3D solids. If you have it set to wireframe, you would only be able to select the wireframe edges. So we will select the solids selection here for solid chaining. And then once again, we are going to do a loop. This will be important which direction that we are going to be cutting. We want to make sure that this is cutting in a climb cutting fashion. We want to be going clockwise around the part rather than counterclockwise, which would be a conventional milling fashion. So we want to move down here to the maybe bottom right corner of this contour, and I'm just going to click on this edge so that it's going to project clockwise around the piece. So we'll click on this edge. We can see that my arrow is running around clockwise. If your arrow is not going clockwise around the part, you can always retoggle it here with the reverse selection. It's going to be 2 arrows going opposite directions. One is green, one is red, but I don't have to make any changes there. We'll hit the green check mark, and that's going to be the selection for this contour finished pass. We'll move down here to the tool tab. Inside of tool tab, we were using the 5/8 roughing end mill. However, this last 5 thousandths that we're going to cut for the wall and the floor, we are going to use the finishing 5/8 end mill, which is the third tool in our tool library. So we'll click on the third tool here. That's going to be the 5/8 flat end mill F for finishing. It actually has a different set of speeds and feeds. We are going to be pushing this tool about twice as fast because we're cutting not a whole lot of material away, which is 5 thousandths, which is basically just slivers at this point. So inside the comments, we will make this 0.625 end mill, and we'll name this finish. Move down here to the cut parameters. Inside of cut parameters, we want to make sure that the stock to leave on walls as well as the stock to leave on floor is set to 0 and 0. If you see any amounts here, just make sure that you change that to 0, and that should be good for a finishing toolpath. Inside of the depth cuts, we do not have to turn that on. We're going to use the entire length of the tool to cut this side wall here, so you don't need to turn on depth cuts. Move down here to lead in, lead out. Inside of lead in, lead out, we want to make sure that that is turned on because we don't want to be making these right-hand cuts. We want to ease the tool in. We're going to roll the tool in. Again, I use the example of driving a Formula 1 race car. If you're taking a turn at 200 miles an hour, you don't want to take that at 90 degrees. You want to ease into that curve. You want to ease into that turn. So that's going to allow us to do this nice chip thinning. We're going from thick to thin cuts. So let's leave that lead in and lead out on. And then we're going to go down here into the linking parameters. So inside of linking parameters, again, we always want to make sure that we're registering as absolute, 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 and absolute. We will change this to absolute, 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 and absolute. Like we did with the dynamic mill, we're just going to update the top of stock and the depth here. So top of stock should register as 0. We'll click on top of stock. We'll click on this top edge right there. That's going to be 0. And then depth, this is currently set to -5/8. We're going to go 60 thousandths below this bottom surface so that, again, we can clean up for second operation. So we'll click on depth. We'll click on that edge. Again, we are still seeing that it is -0.625. I'm going to add, or in this case, since there's negative numbers, subtract 60 thousandths, and we should get that value of -0.6875. With the green check mark, and that is going to project that contour toolpath around our entire model. So once again, let's go ahead and check this and verify. I'll select my entire toolpath group from the operations manager on the left-hand side. We'll click on toolpath group 1, and we'll select on the half pipe looking icon for verify. And again, we should see this in the color loop selection. So each one of these toolpaths should be a different color, and we can see that the purple here is the finishing contour toolpath going to the finished size of the 3D model. So we'll hit the X button and back out of verify here. This all looks great to me. And then we can move on into our next toolpath, which is actually going to be this step here from the top surface. So we're going to go down one step, and I think we can go ahead and access or use the 2D dynamic mill once again. So we're going to remove this top step here from the top surface to the step. So we're going to go over here to the 2D gallery. Inside the 2D gallery, we're going to click on 2D dynamic mill. Once again, we'll click on 2D dynamic mill. And we do have to satisfy 3 criteria, so machining regions, machining strategy, and then our avoidance region. So for the machining region, we're actually just going to step ourselves in, so no longer are we going to consider the entire stock material because we just removed that using the 2D dynamic mill and the contour in the previous operations, so we don't have to consider this outside edge. So for our machining region, we're just going to use the finish contour, so we'll click on machining chains. This is still set to the 3D model. We'll select the bottom contour here of this entire profile. So we're going to grab that entire outside edge. We'll hit the green check mark. That's going to be the machining region. Again, we are going to make sure that we are cutting this here from the outside. So we will change our machining strategy or keep our machining strategy here to from outside. And then lastly, we will have some avoidance regions to consider. So right now, if we're trying to cut this step, we want to keep these diameters at the levels that they're at from the facing operation, so we don't want to cut through or change these levels right now. So our avoidance region are going to be the outside diameters of each one of these cylindrical surfaces. So we're going to click on avoidance regions right here, click on avoidance regions, and then we're just going to select on the outside edges of each one of these top surfaces. We'll hit the green check mark, and again we had 3 criteria to satisfy before we applied this toolpath. We had machining region, which is going to be the outside contour. We changed our machining strategy to from outside, and then our avoidance region are going to be the outside diameters of each one of these selections. We'll hit the green check mark, and then we'll move down here into our tool tab. And like what we did before, we're going to toggle between a roughing tool and a finishing tool. So we're going to rough this out first. So we'll select the second tool, which is going to be the 5/8 flat end mill rough. So you should see the R afterwards. And then our comment should be 0.625 end mill. And then we'll just say rough step. So we're going to do that first step there. And then we'll move down here into our cut parameters. Again, we are going to leave 5 thousandths on the floor and the walls, so you can leave this here as 5 thousandths. It's still remembering the last values that we used. We will keep or maintain our step over distance as the default 25%. And then again, we don't have to change our depth cuts, so you don't want to have this turned on. We'll move down here into linking parameters. Just double check that we are working in absolute, 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 and absolute. Top of stock should register as 0, so we'll change that to a 0 value. Depth, since we selected the bottom contour here, it is recognizing that we're trying to go down to -5/8, which would be quite a deep cut. We want to actually go to that first step here, so we're going to click on depth, and we'll click on one of these top edges of that step. So we're only going to be going down -0.125. We'll hit the green check mark, and you can see that we are projecting that toolpath around each one of those circles or each one of those diameters. And let's just take a look at what this looks like inside of verify. So we'll select our entire toolpath group here. We'll go to verify, let that load, hit the play button. It's going to be the contour, and then here inside the inside edges, we're actually cutting this down so that we can maintain the step from these top edges to this bottom surface right here, or that top surface of that top step there. So that all looks pretty good to me. We just have to finish this top step. However, if we back out of verify, I'm not really pleased with what this toolpath looks like for the dynamic mill. That's great for roughing material. We're just trying to remove material as quickly as possible. But for a finishing operation, I don't want to see all these random toolpath lines. I want to have nice step overs going from one toolpath to another toolpath to another toolpath. So I'm going to actually use a different toolpath here called Area Mill. And if you wanted to, you could follow the exact same steps and go into the 2D gallery with the drop-down menu, and then go into Area Mill, and then select the same selections for the outside contour, avoidance regions, machining strategy, all that fun stuff. However, we already have all this pre-selected from the 2D dynamic mill that we just completed. So we're just going to copy and paste this toolpath, and then we're going to edit it and change it over to an area toolpath here in just a second. So inside your operations manager, I want you to select on that fourth toolpath and make sure that you have a check mark next to that toolpath and that toolpath only. If you have check marks next to these other toolpaths and you go to copy and paste, you will copy and paste all four toolpaths. We only want to copy and paste this fourth toolpath here. So again, I just want to see a check mark next to this 2D dynamic mill. We'll right click on it, and then from the drop down menu, we're just going to go and find the copy option. So click on copy. And then right down here, we should see a red arrow. To the right of the red arrow, we're going to right click on it. And then from this drop-down menu, you're just going to click on or select paste. So we're just pasting this toolpath, this 2D dynamic mill that we just completed. And if you click on parameters, this is going to open up your parameters page. We're just going to come up all the way here to the top to toolpath type. And inside of toolpath type, you might not have noticed this before, but when you go through all these different selections, like the machining strategy, machining regions, avoidance regions, these are going to be consistent through each one of these toolpaths here. So you can actually toggle this toolpath from each one of these selections. So even though that we used a 2D dynamic mill before, we still have the same selections. We're just going to change this over here to Area Mill. So let's go ahead and click on Area Mill. And this is going to create, you can see here from these different graphic views down here, that 2D dynamic mill is going to give you basically whatever toolpath it's going to give you to try to remove as much material as quickly as possible in the most optimized fashion. However, if you go to Area Mill, these are going to be nice parallel offsets for each one of these toolpaths. So I think this is going to be a very great toolpath for us to utilize for this finishing operation. We're going to make sure that we have Area Mill selected. And then if we go down here to Tool, we're just going to change this from the 5/8 flat end mill rough, and we're going to change it to the 5/8 flat end mill finish. So we're going to click on the third tool, and again, we should see an F after the end mill here for finish. And whenever you're changing tools, when you copy and paste, you have to reinitialize the speeds and feeds. So the speeds and feeds are currently set to the old values for the roughing. So that's a spindle speed of 4,500, and then the feed per tooth is 3,000 per tooth. So we want to change this or update this to the current values from the tool library for the finishing tool. So if you right click on that tool that we just changed or selected, from this drop down menu, we want to reinitialize the speeds and feeds. So if you click on reinitialize speeds and feeds, this is going to update the correct spindle speeds and feeds for this tool that we're going to be using for the finishing operation. So you can see that the spindle speed has now doubled. We are going to 9,000 revolutions per minute. We also have to update the note here because we copied and pasted it from the 2D dynamic mill before. So a 5/8 flat end mill rough step, we are going to change this from rough to finish. Put a space here. Okay, and then we'll come down here to the cut parameters. Again, it is still remembering those values that you copied and pasted. So the stock to leave on the walls and floor are still registering as 5,000s. We are going to zero this out, change these both to 0 and 0. We can label the step over percentage here to 45%. If you wanted to change it to the 25% that we were using before, I'll just show you what it looks like. I'll change it to 25. We don't have to update or change our depth cuts. And then here inside of linking parameters, this should all still register as the same selections, but just double check it that we are in absolute, 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 absolute. Top of stock is going to be 0. Depth is going to be the top edge of that first step. So that should register as negative 0.125. So when we hit the green check mark, we should see a very nice parallel offset toolpath get generated here. So you can see that we are generating this toolpath. All these projections are going to be parallel to each other. And this is going to be, in my opinion, better for finishing, because if you're trying to polish this or do any like hand finishing, it's just going to make the grain of the material easier to follow than these random toolpaths. Now, one thing I want to mention here is this entry motion. You can see this helix green entry motion. If you are getting a projection where it's maybe ramping in left to right, That's because the entry motion helix is actually set to too large of a value. So if you go into the parameters of this toolpath and you go to entry motion, this is giving us a radius of 0.2875. If this was set to a high value like 0.75, sometimes it defaults out to a high value like that, you will see these ramps going left and right in that green selection. So if you wanted to update that and change that, all you need to do, and in my opinion this is a good rule of thumb, if you change this entry method, the radius should be half the diameter of the tool. So if we have a 5/8 tool, so 0.625, and we click on divided by 2, you should get a value of 0.3125, and if you hit the green check mark, you will get that nice helix entry motion, which is going to be better on the tool. It's going to cause less stress. So this looks pretty good to me. Let's go ahead and select our entire toolpath group 1 so that all 5 of our toolpaths are selected. We will click on Verify Selected Operations here from the top toolbar. Click on Verify Selected Operations, and we go and click on the play button here. We roughed, we're finishing, we're going to rough and then finish this as well. And if I want to see what this looks like against the finished stock model or the reference here, we're going to click on the workpiece from the Home tab inside of the Verify window. So we'll click on Workpiece. We're going to turn that on, and then we'll go ahead and click on Stock. Again, these are 3-click radio buttons. We'll click on Stock once, and that's going to make our stock material transparent. So this is looking pretty close to matching up. The only thing that we are missing right now are the center pocket as well as these drill holes on each one of these edges. So let's go ahead and take a look at this center pocket first, and then we'll finish up with our drilled holes last. So I'll toggle this back here so that my stock material is completely opaque and that we turn off our workpiece as well. So I'll back out from Verify and return into the viewport of MasterCam. Let's go ahead and make some room over here on the left-hand side in our Operations Manager. I'm just going to minimize all of these toolpaths, and then I can actually toggle off the visibility of these toolpaths as well. So right now I have toolpath group 1 selected. I should have a check mark next to each one of these toolpaths. Up here above the Operation Manager, we're just going to select on the second icon in the second row. This is going to be toggle display on and off selected operations. It's going to be these 4 waves. They're not going to be highlighted in. They're just going to be the 4 blue waves. We'll click on that, and that's going to toggle off the visibility of those toolpaths. So let's go ahead and focus on this center pocket here. And we can follow the same suit where we're doing like roughing and finishing. And I think for us, we should still utilize the roughing operation from the 2D dynamic mill. I still think it's a great toolpath to utilize, even though that it's an interior pocket here. So we'll go ahead and click on the 2D dynamic mill. And before, we've been making all these 3 different criteria selections for machining regions, machining strategy, as well as the avoidance regions. And I think now we can maybe start to spoil ourselves a little bit because you understand how that toolpath works. And we're actually going to try to select the automatic region. So we'll click on this automatic region up here. We'll click on the pointer right there. And right now this is going to allow us to select a face from the 3D model, which is going to be this bottom surface or this bottom pocket inside of this pocket right here. So we'll click on the bottom surface right there. It's going to select on that entire surface. We'll hit the green check mark, and then we'll hit the green check mark once again. But before you do that, one mistake I just made, make sure that we are not doing from outside. I will leave this as a bad example. I will leave mine as from outside, but you want to make sure yours is stay inside. If you already hit the green check mark here, you can make this change here in the next window. I'll show you here just really quickly. But I will leave mine as from outside to show you as a bad example, but make sure that yours is set to stay inside. So we'll hit the green check mark. If you already hit the green check mark when I said I made a mistake there, you can toggle this here for the machining region strategy. You can toggle it over to stay inside or from outside. So make sure yours is stay inside. Again, I will show you a bad example of the from outside. And then I will go down here to tool. We will use a different tool from the 5/8 flat end mill because I think it's just a little bit too big to access effective material removal for this inside pocket here. But we are going to use the 312 end mill, so we're just going to go down to the 4th tool here, and inside the note we'll name this 0.3125 end mill, and we'll just say rough pocket. Okay, and then we'll move down here into the cut parameters. Inside of cut parameters, we are still going to utilize that same stock to leave on walls and floor as 5 thousandths. Now we will be accessing the depth cuts now because we're going to be doing this inside pocket. We're going to be putting cutting pressure on both sides of the tool rather than one side of the tool when we're approaching from an outside cut. This is going to be an inside cut. And if you look at the suggested depth cuts that we have for the 5/8, or sorry, the 5/16, the 0.312 flat end mill, this is going to be 0.15625. So a good rule of thumb when you're doing interior pockets, in my opinion, if you want to be conservative, is going to be half the diameter of the tool. So we have a 0.312 5 diameter tool, or 5/16. And if you go down here to depth cuts, we can turn depth cuts on, and then I'm just going to type in 0.312, and then we're going to divide that by 2, and that's going to give you your 0.15625, which is going to be the depth here that we're seeing for the recommended depth per pass for the 5/8, or sorry, the 5/16 flat end mill. Okay. All right, then we'll move down here into our linking parameters. Inside of linking parameters, we do want to make sure that this is still registering as absolute, 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 absolute. Top of stock, we will change this to the top edge of that first step because we removed that material already. So we'll click on top of stock and we'll click on one of these top edges here. We are going to register top of stock as negative 0.125 or negative 1/8. And then depth, it is registering as the correct value because we selected that bottom surface, but just make sure and double check that we are getting negative 0.5. So we'll click on depth, we'll click on one of these bottom edges here, we are getting a value of negative 0.5. With the green check mark. And as I said, I was trying to show you a bad example. I'll show you what this looks like when I verify, but I had mine set to from outside. If you didn't have the machining strategy to inside, you're actually going to cut through some of the model here as we're cutting this. So you can see that we're cutting through these selections to reach this pocket, which is not what we want. So from outside in this selection is actually going to hinder you in this programming operation. So I'm going to go back into that 6th toolpath, and if you had toolpath type here, stay inside selected, hit the green check mark, your toolpath should look something like this. And we'll go ahead and select the entire toolpath group here. We'll verify that once more, and we'll hit play. And you can see that when we are doing this from inside selection, we will not cross over or cut into any of the geometry to reach this pocket. We are staying within the extents of the pocket itself, and we're not crossing over. So again, we are doing a roughing operation. One thing that you might not notice is if we go to the home tab and inside the visibility, we'll go ahead and turn on the workpiece, and then the stock will toggle that once. If you zoom in here, this tool is not small enough to clean up these corners. So we used a 5/16 flat end mill to try to clean up or rough this pocket. However, it is not going to reach the bottom extents of these radii because the tool is just a little bit too big. So something that we have to consider is to measure some of these internal pockets so that we can cut with the correct size tool to get a full swing of this radius. So I'm going to back out of verify here really quick. I will return back to the isometric view so that we can see the entire model. If I have my entire toolpath group 1 selected, I will toggle off my toolpath so that's just a little bit easier to see. And what I'm going to do is I'm going to go over here to the Home tab, and inside the Home tab, I'm going to utilize this Analyze Entity selection. So we're going to click on Analyze Entity, and if I click on this radius here, I can see that the radius value is 0.135, and if it's doubled, so the diameter here, so the diameter would be 0.27. So in my mind, I have to choose a tool that's smaller than 0.27, which should, in our instance or in our tool library, be a 250 or a 1/4 inch end mill. So we'll hit the green check mark, and we're going to use a 1/4 inch end mill to finish up this pocket. Now, again, we could utilize that same workflow where we're copying and pasting this 2D dynamic mill. However, I want to show you a really powerful toolpath that I like to utilize for finishing operations inside of pockets. So we'll return back up here in the top ribbon all the way over here to the right into the toolpath tab. And inside of toolpaths, we're going to actually expand out the 2D gallery. So I'll hit the drop down menu here for expand gallery. And we're going to look for the pocket selection. It's going to be the second icon in the second row. We'll click on pocket. And just like what we did before for the selection of the 2D dynamic mill using the automatic selection, we're going to keep ourselves here for the solid selection, and we're going to select on faces. If you wanted to, you could do loops, but when you're doing loops, you have to make sure that you're going to be cutting counterclockwise because everything is going to be reversed if you're going to be still using a right-handed tool spinning clockwise. So we want to make sure if we are selecting loops, we are going to be doing it counterclockwise. Everything is reversed because we are going to be inside of a pocket rather than outside of the pocket here. But if you are using the face, you will not have to worry about this. We can just select on face. We'll select on this bottom face right there with the green check mark. And then we'll select on tools. And like I said, from the investigation of analyzing the entity, we identified that those radii are 0.135, or we would have to use a diameter tool of a minimum 0.275. So we are going to use a 250 N mil, which is going to be our fifth tool. So we'll click on the fifth tool here for the 250 N mil, and we'll say that this is going to be 0.250, and we'll say N mil, and then we'll just say finish pockets. Okay. Then we'll jump down here into cut parameters. As always, for a finishing operation, we want to make sure that we are zeroing out the stock to leave on the walls and the floors. Currently set to 50 thousandths. We are going to change this to 0 and 0. And then we're going to come down here to roughing. And this is why I like using the pocket 2D, or sorry, the 2D pocket toolpath when doing finishing operations, because it allows you to control what the toolpath is going to look like when it's finished projecting or generating. So here inside the roughing, you can see that we can optimize this toolpath for zigzag, constant overlap spiral, parallel spiral, and a bunch of different selections here as well. And to be completely honest, you are not going to get this control over a 2D dynamic mill selection. It's just going to give you whatever it wants. Same thing for area mill. It's going to give you probably a pretty good toolpath for like offset equal offset toolpaths, so like a constant overlap spiral or a parallel spiral here. But when you're using the 2D pocket toolpath, you have a lot of control over what this finished toolpath is going to look like. So if you're working on this, you can choose pretty much any one of these that you want. I like to use either constant overlap spiral or parallel spiral. So I'll click on constant overlap spiral. We also have the ability to control the step over percentage. So we'll kind of match this up to what we were using for that 2D dynamic mill before. Right now it's set to 50%. We can go to 25%. 50% really isn't bad because we're only cutting away like 5 thousandths on the floor and the wall. But we'll hit enter there, and you can see my step over distance gets updated to 0.0625 or 60 thousandths. We'll move down here into the entry motion. This can all be the same. If you aren't getting the correct entry helix like we were talking about before, you can update this or change this. Take the diameter of the tool and divide it by 2, but it is already doing that for me. Minimum radius is giving me a 0.125. And then lastly, the reason why I love this toolpath so much is when we're here inside of finishing, you can create multiple finishing passes inside of the same toolpath where you don't have to create a separate contour toolpath for that final edge. So inside of finish, I can change this from 1 pass to 2 passes, and I can update the spacing to whatever value that I want. So I know that on the wall and the floor we left 5 thousandths, so we have 2 passes. I'm going to take that 5 thousandths divided by 2, and we're going to make the finishing pass here on that outside edge shrink down to 2.5 thousandths for each pass. So I'm going to say 0.005 divided by 2. Hit enter. That's going to give me that 2.5 thousandths per pass in the spacing for this finishing, and we're going to have 2 passes at 2.5 thousandths. This is going to be pretty great. We're going to move down here to the lead in and lead out. We should be able to leave this on. If this is giving you any errors, especially with tight pockets, you might have to turn in and lead out off because it's just not enough room to kind of swing the tool in there for a lead in and lead out. So in this instance, we should be able to lead in, lead out on, and then we'll move down here into depth cuts. Since this is a finishing pass and we're only cutting away 5 thousandths, we really don't have to update this or turn this on like we did previously with the 2D dynamic mill for the roughing operation using that 5/16 N mill. So we'll leave depth cuts off and then move down here into linking parameters. As always, just with any other toolpath, we have to make sure that we are setting this to absolute, 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 absolute. Since this is a new toolpath and we haven't used it before, it isn't recognizing that we've used absolute, 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 absolute before. So go ahead and toggle this to absolute, 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 and absolute. Top of stock, we are going to make this the top edge here. And then the depth, this is registering all the way down here to -5/8. We are trying to go to -1/2, so we'll go to depth, and we'll go to negative 0.5 to this edge, and that all looks good to me. And then we'll hit the green check mark to generate that toolpath. And this is, again, why I love this toolpath so much. You can see these nice equal offsets for the toolpath as it's cutting. And then the last couple passes in that finishing selection that we made, we were able to control how much the tool was going to step over for each one of those finishing passes. So we said that we were going to do 2 finishing passes. That's going to be the 2.5 thousandths there and there. And then this last pass over there was going to be the offset from this value right there. So to me, this is a really great toolpath. It's going to give you a great surface finish when it's finished up here. So let's go ahead and see what this whole thing looks like and verify. I will return back to the isometric view. Oops. And then I'll just zoom out a little bit here so we can see the whole thing. And then I'll select my entire toolpath group, and then we'll go to verify the selected operations. And then again, we have the workpiece still turned on, and then the stock material is transparent, so we should be able to see if this matches up to the finished surface. Before, we were looking at the corner radii and why they weren't cleaning up using that 5/16 flat end mill because it was a little bit too big, but now that we're using the 250 end mill, we should be able to see that the tool is going to clean up in all of these corners now. So you can see that we are matching with the provided 3D model, and this looks like a perfect surface finish for that 3D model. So let's go ahead and finish this up by taking a look at these 3 holes here. This is going to be a simple drilling function. And we're just going to move over here into the 2D gallery. We'll hit the drop-down menu. We'll access the drill command, so we'll click on drill. And then for me, I like to just drill out as many holes as I can with the same tool. So even though that this hole is a little bit bigger, I will pre-drill it with the same tool. So we will go ahead and select this hole, and this hole. So we have 3 holes selected. In the left-hand side, you can see that the diameter goes to 250, 250, and then a 1/2 inch. We'll go ahead and use a 1/4 inch drill or a 250 drill to open up all these holes. And then our last operation will be to open this hole up with a 1/2 inch drill. So we'll hit the green check mark. Move down here into tools. We'll scroll down a little bit and try to find our 1/4 inch drill, which is going to be tool number 8. We'll name this 0.250 drill. And then we'll move down here into our cut parameters. If you wanted to, you could do a peck drilling operation. I'm pretty confident in these tools. We have really great drills in our machine, so I'm going to leave this as the default drill counter bore. I don't have to go and peck drill this. And then move down here into the linking parameters. I do like how this is shown now with these different planes. However, you still have to change this all over to absolute, 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 absolute. I do miss my radio buttons here, but I do like the added visibility of these planes. The only thing you have to do now is actually hit the drop-down menu for incremental, change it to absolute, hit the drop-down menu for incremental, change to absolute, and then lastly, we'll change the depth here from incremental to absolute. Top of stock is still going to be 0, so we'll click on that 0 right there. Depth, we are going to go to the bottom of the part. Click on the bottom of the part there. And then we do want to make sure that we turn on the tip comp. Another added bonus here for the update in 2024 is this added tip comp. I really like that they added this to the linking parameters page and it's not on its own page anymore. So we're going to click on tip comp. And since we imported this tool library, it already recognizes what tip angle that we're going to be using because I already set it up for you. But in this instance, we are going to be using a tip angle of 140 degrees. And like what we did before, we're just going to go 60 thousandths below the finished surface. So we're going to go 0.0625 and hit enter. And we're just going to go 60 thousandths below the finished surface or the depth that we chose in this previous selection. So we'll hit the green check mark. And we can see that the the drill is traveling 60 thousandths below the finished surface, so that all looks good to me. And then the last toolpath operation that we're going to take a look at here is going to be the 1/2 inch drill for this big hole there. So we'll go and click on the drill once again. We'll select on this hole and this hole only with the green check mark. Click on tool. We'll scroll all the way down and we'll find the 20th tool, which is going to be the 1/2 inch drill. Title this 0.500 and we'll say drill. And then we'll move down here into cut parameters. Again, we don't have to do the peck drilling, especially since we pre-drilled this with the 1/4 inch drill. We almost created a pilot hole so we can drill through the entire depth of the material in one shot here. And then we'll move down here into linking parameters. It's still remembering the last values that I selected, so absolute, absolute, absolute. That's great. Top of stock, we will leave that as 0. The depth here, we're going to change this to the bottom surface. And then we still have the tip comp turned on. With this specific tool, we're actually using a 130 degree angle, and then the tip comp amount that we're going to break through is going to be 60 thousandths. So we'll hit the green check mark, and again, that should cut through the entire model. We'll select our entire toolpath group, and we'll see what that looks like and verify. And then we'll hit play. And again, we're doing roughing, finishing, and then we'll finish up with these drilled holes. So right now, the stock model is matching the provided workpiece or the imported 3D model that we brought in from SolidWorks. All these edges are matching up. This looks really great to me. I'm going to toggle off my workpiece really quick, and then I will change my stock to completely opaque. This is what your model, your finished model, should look like. And if you wanted to, you could start to experiment and explore with edge breaking. However, this one's going to be a little bit more difficult with edge breaking since the tool might intersect with the extrusions here of these cylindrical surfaces or these diameters as it gets closer to those edges. So just keep that in mind. However, I'm happy with how this is finished up here, and I'm going to say this is going to complete our first operation for the bracket exercise P1. So I'm going to return back here to the isometric view. You can go ahead and save this, and then we'll continue on in the next video, finishing this up with second operation and importing our soft jaws and seeing how this all assembles. So thanks for watching, and I'll catch you in the next one. Bye.